Alright, BCA-101. This is for Wednesday, the 26th. I think day 22, we're in week 9, going to week 16. And the first thing we're going to do is a little review from Monday and lead into Wednesday's work. So, we had the internet outage over on the East Coast, and we talked about the Internet of Things, or sometimes that's referred to as the Internet of Everything. And we had a distributed denial of service attack. And they used a botnet. More or less they got a whole bunch of devices that are not secured good enough. And they had all those devices attack domain name services, which caused an outage because people couldn't use the domain name to get the IP address to get where they want to go. It's a great example. More later we talked about mail and how we encapsulate the letter, and we encapsulate it with addressing. Same thing's true in communications and the web. We have a device. Good example, going to a web server. So we're going from the device to the web server back to the device, and we're going through some network or networks. So communications is a big deal in our world, so we have rules so that they understand the communications from the device to the web server and back. Those are called protocols. Transmission control protocol, IP protocol. This is what makes the internet work. There's more protocols than that, but that's the main one. Locally, we use Ethernet, either a cable or we use some type of Wi-Fi. If you remember, Ethernet 802.3, Wi-Fi is 802.11. These are more specific numbers, but these are extremely popular. An important term, bandwidth, I like to draw a pipe. It's how many bits per second we can send. And we'll be talking more about that in networking. What do we send it across? In the air, on wire, or through fiber optics. We talked about addressing. Devices have a physical address, and then when you are in a particular location, you get a logical address. Like if you walk in McDonald's and you get on their Wi-Fi, if you look at your phone or your tablet or whatever, your laptop, you will see it obtaining an address. Maybe not always, but typically. So it's an address that's going to work in that location. And it's still going to be able to use your physical address, because those are unique to every device in the world, so it can use that to find your device at McDonald's. Okay? IP addresses, private, public. Public ones we use on the internet. So when you are at McDonald's, right, whoops, there's the arches, and you're sitting here in McDonald's, you have a private address, but when you leave McDonald's to go to the internet, they give you a public address to use on the internet. And that address then would point at the ISP that McDonald's are using. Yeah. We'll keep moving here. Good stuff. So here's another good example. We have a work server that we can access on campus using this private address. That's a private address right there. It's a private IP address. And that one is unique to our area of the network. So if you go to draw a cloud here, whoa. The IT area, nobody else has that number, and it's assigned to that work server. Now if you're at home and you want to get to the work server, what we do is we do network address translation. We take this address and match it with this one. This is a public address. Okay? That address is unique in the internet. We got it from our ISP, the Iowa Communications Network, assigned that to NIACC, and then NIACC assigned it to this area. So it's different than other ones at NIACC going this way. This is the rest of campus. Okay? So when you're at home, you can use the public address to access the work server. So you use that, the internet knows it belongs to NIACC. NIACC, this router sees it and it knows it belongs over here. When it gets to this router right here, it does NAT. It converts it from the public to the private, and then it puts a MAC address on there so it goes right to the right computer. Crazy. So when you see google.com, really it's the IP address that gets you somewhere. Okay, so we have domains and domain name services. So when you type in google.com, it can go here, can get the IP, and then send you to the right place through the internet. So, on Monday, or excuse me, on Wednesday, we actually restarted the computers. We booted them to Windows 8. We use this as a login and this as a password, and then we checked the network adapter to see how it's set up. Is it set up for DHCP or static IP addressing? So we reviewed that. I mean, for a lot of people, it's the first time they've ever seen it. DHCP is your device gets an address automatically. Static means it has an address that it keeps forever. If you have a mobile device, like a laptop or whatever, and you move around to different networks, you always have DHCP set. In fact, in a lot of computer labs and so forth, it's set that way, so it automatically gets an address that matches where it's at, network-wise. Okay? So we checked that because they had to be set for DHCP in order to work for what we wanted to do. We talked about Unit 4 completion, and if you haven't, you need to complete that up. That's due Thursday night of this week. So discussion, we talked about pictures online. That was kind of fun. We talked a little bit about the outline, and you need to finish assessment. So you need to be caught up in those things. So really, moving into Unit 5, you really just have the assignment to worry about. There's a discussion forum to start, and then you need to be working on your outline. This you will see in some work. That's the password to get into that work server that we were talking about. Next, we showed this line kind of where the end devices are. Okay, so these are like end devices. A PC connected, some servers would be considered that. A printer would be an end device, your tablet, smartphone, all these devices that want access into our network. You think of this red line kind of like the cloud. They need access in. Okay, since people, not always, but there's people functioning at these, okay, there's always the risk of security. What are they actually doing with the device? Not quite as much here, but it's still outside of that, and it's still an end device. Okay, talk more about security later. Inside here, we have network equipment. Just a few terms. This is a multi-layered switch. This is a switch. I'll write down up here. That's a switch. That's a router. This is also a router. There. Here's another multi-layered switch. We have firewalls, and then access points, and then there's a couple more. But most local area networks function this way. So you have end devices that are going to connect into these devices, and then they're going to move the traffic through. Like if you're going out to the internet, or you could be on this computer and you could go in to this network and do something like NIACC web page or something, and so forth. Sorry, it's getting a little long, but let me finish up. I got 2 slides left. So let's go back to drawing our lines. So we have this connection in to the network. So we're trying to get in through these network devices, and these are end devices out here. Okay. And so, for example, we talked about if you are on a smartphone, you connect it to an access point, and that took you into this network. You could go in here, somewhere's in there, network address translation, your private address that you got out here. You got it with DHCP. You didn't even see it happen. It just happens. It gives you an address, and then it remembers your MAC address right in here somewhere. Just don't have to worry exactly where. And then it gives you a public address that you can use out on the internet. Okay? So if you're at home, it'd be the same thing. Here we have another device, a modem, cable modem. They talk about broadband. That means they have multiple signals on our cable modem. We have data, so I can use the internet, and we have TV. Broadband is multiple bands. You might have a smart TV in your house connected to your network. So then, same thing happens at your house. Network address translation, your private addresses. Oops, I'll write them in red just for the heck of it. You know, most private addresses at homes are 192, 168, something with these dots in there. Learn a little more about that later, but that gets NAT. And where do you get, whoever your ISP is, I'll write it in red here, whoever your ISP, like MediaCom gives us a number from our house, and that same number is what we use when we go out the internet, whether we're going here on campus or I'm getting into our network or whatever. So here's the big picture. I don't think I need to say much here. You can see, so even at your home, you got that fine line from where your equipment, your end devices connect in, and then networking devices move the information around that are mostly, what are these? Think about it. What are they? Okay. The routers. That's a switch. That's a multi-layered switch, which is a router and a switch built into one. And you have this device at home. If you have one of them little, they call them routers at home. You might call it a router or a VPN router or whatever. But that is all of those things. It's a switch, it's an access point, and it is also a router. All built into one. Okay, yours probably costs $40 to $100. This one probably $20,000. This one not as powerful, about $2,000. And then in the internet, where everything moves through, it goes from router to router to router, and it just they call them hops. And it works through, and then it goes to wherever you want to go. So it finds the network you want. Learn a little more about it. So, key things to take away. Every device has a physical address, and that's how your device is uniquely identified when you have it, no matter where you are and you connect to the internet. media access control. How do you access the media, right? How do you access the media? And that could be Wi-Fi, wired, or it could be fiber optics, but most typically it's one of those two for your device. When you are at some location, you get a logical. The reason we call it logical, it's not tied directly to your device. You get one of these depending on where you are with that DHCP. You know a whole lot about that. And nowadays, these are what they call an Internet Protocol number. And then that number is typically private when you get it. And then there's network address translation and turns it into a public address to use on the internet. And that's it.